Okay, good morning, everyone. First, I'd like to thank Geoff for joining us all the way from Australia, where it's 5 in the afternoon. First time I met Geoff was, if you remember, 26 years ago. Physically, we met in Geneva at, I think it was one of the IETF meetings, but we were mandated to become part of something called the IHC, which later became IPOC. And nowadays, everyone knows it as ICANN. So Geoff and myself were involved as the precursor to forming of ICANN. Geoff is prolific in the amount of articles that he writes currently for the Internet Protocol Journal. Anyone who doesn't have a subscription, please go and get it, because it's a fascinating place to learn all about different Internet protocols. When I knew Geoff back in 1996, 97, he was the chief scientist at Telstra. Now he's the chief scientist at APNIC. And I was even able to find a book in my library, Quality of Service. Now, those of you who remember back in the old days, quality of service was the buzzword before everyone decided basically internet networks need just to be over-engineered, and it's cheaper than building in quality of service. So I've known Geoff for a long time, and it's really a pleasure to have him online with us. And I'm basically trying to eat 1 or 2 more minutes so more people log in. But now I guess I'll give the floor to Geoff. You have presentation enabled. Floor is yours. And if people have questions, try to keep them to the end. Geoff will definitely take questions at the end. We're scheduled for about 45 minutes, including questions. So the floor is yours, Geoff.
Thank you very much. And this afternoon, I would like to share with you, about the last 10 years of my life. Because over that period in APNIC, I have concentrated like crazy on measurement. And first, let me sort of show you what we can see just by looking. These numbers are not right, but they're not completely wrong either. They're accurate to within, I think, about 10 to 15%. There are 3 pretty large providers, maybe 4, and then another 3 or 4 who I'd say are second tier in Israel in terms of their market penetration for eyeballs. Now, there may be other metrics of networks, but this is roughly the size. So AS 12400 is the big player here. 1680 and 12849 come in as well, and one other. V6, for example, big push over the last 18 months, now hitting almost half the population of Israel who are quite capable of reaching IPv6 servers anywhere. So an extraordinary amount of effort quite quickly over the last few months. In terms of DNS security, wow, again, around 40 to 50% of the population here in Israel actually will not go to a DNS site if DNSSEC validation fails. They will not go. Oddly enough, there are a few more, about another 10%, who, when DNSSEC says, nah, someone's lying at you, they go, it's okay, I know a resolver that won't validate. Let me go there anyway. Oops. But even so, 40 to 50%, that's a remarkable achievement. Who's doing this? Well, Cellcom, Bezeq, and some of the smaller ones, Xphone and so on that list. The ones that have a big number in DNSSEC validates are actually doing it on behalf of their customers. And who uses what resolvers in Israel? Interesting. About half the population use the resolver given to them by their ISP. And a bunch of others don't. Google serves around 10 to 20% of the population, which is a huge penetration. Even by Google standards, that's an awful lot. So there's a lot of folk using Google. As for the others like Cloudflare, Quad9, etc., nah, don't even come into it. And there's a big breakdown as to who uses what. I just wanted to give you a flavor, because this is the kind of stuff that I suppose I've been obsessing about for some time. And as folk who operate networks, I'm pretty sure you have the same kind of questions in your head. What's the measurement approach you're trying to use? And then how to perform it. There's certainly no end of SNMP variables, gang models, etc., where you can look at every component of a network and go, yes, there's this much traffic going through that interface and so on and so forth. But does that equate to a user experience? Looking at the components of a network and trying to recreate the network as a service delivery is always going to be tough. Do you take a snapshot and go, well, this 1 second in time is all time? Or do you really try hard to take time series measurements to understand the fluctuations of service outcomes, etc.? And of course, how do you perform this measurement? Do you probe into the network and disturb it as you go? Or do you try and sort of instrument it so it's purely passive? Do you put probes out there, or do you enroll users like in SAMNOS in the US with that FCC sponsored program, where the customer's consumer premises equipment, that modem, becomes an active point of measurement? Is this deliberate or intentional, or do you just opportunistically pick up data on the fly? There's a lot of ways of doing this, and trying to understand what you're trying to do and how is, I think, an important part. So, as I said, this is actually, it's 12 years of my life now. Gosh, time flies. Why am I into this? Well, at the time in 2010, IPv4 exhaustion was looming. Something that we've been expecting for 20 years was just about to happen any time now. And the real question was, because we'd thought, oddly enough, as it turned out, that with no more V4, we had to run V6 then and there. And so the real question was, how ready are we? Now, this wasn't the only one asking the question, and there were lots of ways that people used the data that they had to infer the sort of the bigger picture. So if you could see traffic, you counted V6 traffic, connections, all those different aspects of the network, and trying to say, if I see this much V6 over here, does that mean the network is V6 ready or not? But quite frankly, none of those answers are very good. They don't really look at the entirety of the experience. All they do is look at V6 in a small microcosm. And what you're trying to do is to say, if I turned on V6 on my web server and turned off V4, how many folk could get to me? And most importantly, how many folk couldn't? In other words, are we ready? Does this work? So the kind of question that we thought we wanted to ask is, of all those connected devices in today's internet, then, now, and all points in between, what proportion of them are capable of making V6 connections? We tried scripting a web page because lots of folks script their web pages. If you went to www.apnic.net, it measured you, whoopee-doo. The problem was measurement bias. You know, the same small bunch of geeks went to APNIC, and that wasn't the whole of the internet. It wasn't even vaguely the whole of the internet. So what we needed was a massively popular web service. The problem is that massively popular web services don't let you script on their sites. Obviously, they're very suspicious of adding third-party scripts, and I can't blame them. I cannot blame them. And so we couldn't really peek over someone else's shoulder. We needed to rethink exactly how to do this. Now, if you Google, you probably don't have a problem except for China, where very few folk actually use Google's Google service. So if you Google, you probably see most of the network one way or another, but Google have a remarkable privacy wall out there, and it's very, very hard to see what Google sees. So being Google is fine, but they don't share. So what you need is to get Google to help you. And what you need to do is to get Google to place your measurement code on literally millions of end user systems all of the time, every day, all of the time. How do you do this? Well, ads. I'm like, when you think about it, it's blindingly obvious, because ads are everywhere. And even the stalwart efforts in ad blockers, even the threats of Apple, haven't really upset the ad apple cart very much at all. Ads are pervasive. And the thing is, ads aren't just pretty pictures. They aren't videos. They're scripting, active scripting. And the script is not just, I'm watching you on hover, on click. It's, I'm fetching network assets as I'm running. I can load alternate images on the fly. I can load up sequences. Now, it's not a full-blown, complete networking environment. And Google deliberately constrained the runtime library because, you know, folk have tried to use ads as virus vectors, probably successfully the first time. So Google certainly constrained the environment or ads are running in. But nevertheless, ads do work as scripts. So if we use on-load scripting, the user does nothing. As soon as the ad hits their browser, it starts to work. So we can instrument this. And the way we do it is that as soon as the ad is loaded, it talks to us, one of our servers, and we tell it what to do. Now, the ad system is actually fantastic for this because the ad system tries to deliver me, the advertiser, with what they call fresh eyeballs every time. So you don't get to see the same ad twice, or if you do, that's a failure of the ad system. The ad folk are constantly trying to deliver your ad to new people. And what we want is a broad sample set that is constantly avoiding repetition bias and constantly picking up new points to measure. Financially, interestingly, you pay a lot for a click. We don't like clicks because we're not interested. We just want the ad to impress. And impressions are way, way cheaper than clicks, way cheaper. So oddly enough, the ad system actually works for folk like us who are simply doing impression-based measurement. So the advertising channel just gives us about 25 million new eyeballs a day. Paying by impression is a whole lot cheaper. And we can actually tune this so that we actually get a selection and we can emphasize ads in certain markets where the ad would normally display. And the other part of this is Google, oddly enough, is greedy. What a surprise. If I give Google a budget of $100 for 24 hours and said, Google, I'll spend up to $100 on ads, go for it. Then by about hour 21, Google says, oh, I haven't spent all of Geoff's money. Let me put this ad on high saturation in YouTube or somewhere else that they control. So at the end of 24 hours, your $100 is spent no matter what. And so what you bid is what you pay. And Google work very, very hard. They don't leave unadvertised eyeballs out there if they could possibly make money out of it. So what do? We set a CPM in the bid. It's low. We pay 2 cents per 1,000 impressions is our bid rate, which is really, really cheap. If you're an insurance agency selling car insurance, you might pay $50 a click. We're right at the other end of that scale. Ads normally do a pretty uneven distribution through the day. So what we did was break up the ad campaign into 24 separate campaigns, each of which only run for an hour. And as I said, Google is crazy about trying to spend your money. And so this evens out the ad distribution across the planet through a 24-hour period. We can also constrain the locale. So normally, because we're very cheap, we don't get a high bid and high ad impression rate in the US. So, you know, we set up a budget of a few $1,000 and go US only. And even though our bid is low, Google want our money. And so they'll work very, very hard to, if you will, place our ad into places that normally they would not place in. So what do we get? We get 25 million ad placements a day, 25 million discrete measurements every single day, all the time. And it's remarkably consistent. That's a 26-hour plot. The purple line there is the total. We do between 200 to 300 measurements per second. And you can see the 1 hour blocking there. As a new set of ad campaigns comes up, it rises up, runs for an hour, and then tails off, and the next campaign comes in. We separate them around. We do a bit of geolocation. So Asia Pacific, America, Europe. India is its own market these days. So many users in India and South America. Now, you'd think that this could be brilliant. I could send mail, I could do viruses, I could do it. No, you can't. You can't do any of that in an ad. All you can do is retrieve a URL. But what do you do as users? You retrieve a URL. I'm like, that's all you ever do. So I'm doing what users do. I basically resolve the DNS of the URL. Once I've got an IP address, I'll send over an HTML query. And that's what you do. That's what all of us do. So if I point the DNS and the HTML to my servers and no one else, and as long as I use unique DNS names, so there's no point in DNS caching, and as long as I'm doing HTTPS, which these days everyone does, then I'm seeing every user as clearly as I can, because I'm getting everything back to my servers. So I use HTML5 code in the ad. It gives me a set of tests, you'll see it in a second, that says, go and fetch these URLs. In this case, there are 10 of them. Bit of dual stack, v4 only, v6 only, object reporting. Here's an example. This is precisely the block of code that the ad gets back from one of our servers. In this particular case, as I did it, it senses that I'm in the Asia Pacific area, and these URLs are directed towards Singapore, because that's the server set we have for this region. And this is a bunch of URLs that the user is going to have to retrieve, or at least try to. And at the end of 10 seconds, there's a URL where it's going to push back what it did. Now, I'm measuring at the same time, so I'm not taking the user's word for it that they got these things, but it's a handy sort of confirmation that the ad ran for 10 seconds and is not incomplete. Because sometimes information that's missing is more important than information that's there. If you cannot fetch v6 object, then that's missing. There's no way of saying, hi, I can't do this, apart from that result line. Now, the DNS is a wonderful thing. I don't know how much you've ever looked at it, but the DNS truly is amazing. Most of you think of the DNS as a static lookup. Label in, look up the database, out comes an answer. Nah. The DNS is microcode. A query name is actually an instruction to a server. And you can embed all kinds of information in a query name that causes the server, if you program up a Dynamics DNS server, to actually do things. So, for example, here's one of the URLs I was using in that screen there. The 0 says, don't wait, execute this immediately, because you can program a delayed response from the DNS if that's what we wanted. The 6 says, this is an IPv6 test only. There's no v4 going on here. So don't give back an A address, only quad A's. S says, please sign this with DNSSEC. Oh, and by the way, use a valid signature. Don't go playing with invalids at this point. There are 10 of these, and I'd like all of them to be wrapped up to find what the user did. So that next field is grouped within those 10, but is unique in all other respects. So that's a UUID, just basically a unique ID. I've geolocated you. Your country code, in my case, is 13. That was Australia. I've also looked up the IP address you hit me with, and that in hex is your AS number, which in my case, I was behind Telstra, AS1221. This is interesting. This is the time the ad ran. How much of the DNS that you see on your authoritative server is stale, is not real, is not time critical, is something else? Tracking, zombies, log replays? The answer is unbelievably high. Around 45% of the queries you see are actually junk. And the way you can find that out is if your query name actually has the time in it. And you can see the difference between this is happening now, this happened ages ago. And oddly enough, because we're interested in the equivalence of v4 and v6, if you came to the experiment over v4, we will use the IP address you came to us back in the DNS name. So that's the hex version of the IP address that hit us. And the last field, that 0, that's a bit of Googleism. Google don't like wildcards. Cool. They want every label, the single label you're allowed to play with, that's why I use hyphens, not dots, to have a constant right-hand side at the end. So I gave them 0. Yay. Go Google. Syntactic sugar. So I run 5 server sets at the moment. 25 million a day is a lot of data. Frankfurt, Singapore, Dallas, Sao Paulo, and Mumbai. And the way this code works is it goes to look for the closest servers, maps you into it. And there is actually, I use Linode, God, who owns that? Akamai these days? A set of dedicated Linux machines running Debian. And there's a dedicated DNS, dedicated web server, and so on, all running on VMs. What do we collect? HTTP logs, because yay. DNS logs, yay. But, you know, every packet all the time, because we only collect basically the headers. The rest of the payload's normally encrypted these days, but that's the one way we can actually see a lot of what's going on in its timing. So let's do a quick look through the data analysis. Who does V6? Well, we actually do 2 fetches. One is dual stack. That says, who do you prefer if you're given a choice? And the other one is V6 only, which is you can only get this if you have V6. If you don't have V6, it doesn't work. Aggregate the data up by origin AS, aggregate it up by country code. Oh, and by the way, because Google isn't exactly even in the way it distributes the ads, we then do normalizing across countries, so that if Google wants to splash the ad like crazy in Australia, but give almost no ads to New Zealand, we balance it up by user population to try and give a sort of an even view across the world. Do this every day. What do we see? Around 30% of the world is now capable of doing V6. Oddly enough, the capability is slightly higher than the preference. There are a number of locations out there where happy eyeballs is not working the way we thought, and that even though V6 is around, some users prefer 4, but a little over 30. You go, why isn't that the same as Google's numbers on their site? And the basic answer is China. Google don't normalize and don't see much inside China. Oddly enough, though, Google ads are right inside China, the same as everywhere else. And once you factor in those 700 million users into the global numbers, because China's V6 is still getting underway, it's a little bit lower than Google's number for the global. That graph is kind of interesting. A lot of work happened in 2017, 2018. And the real question is, how did it happen and where? And the answer very much is it happened in India, and it happened in 1 year. There are a lot of people in India. And when one of the largest Indian providers said, we're doing V6, the world just tilted. The years across COVID, slower, definitely slower than the years leading up. We kind of all took some breath. Where is V6 as a percentage of national users? I said India, and I meant it. Saudi, France and Germany, yes. Finland, yes. Norway and Sweden, no. America, thanks to Comcast, major provider there, a lot. Canada, less so. Brazil, more than its neighbours. And Africa, well, no. And over in Europe, Spain, well, no. Italy, no. But Greece, yay. Let's zero in a little bit more. Those are some numbers for each of the countries. URL down the bottom, and we'll probably talk about that URL a bit later. Israel, I already showed that to you, a detailed view, up around 45%. Those are the ASs, you've seen that. But I actually have enough ad penetration to plot the chart of each network. So Partner AS started this journey in July of 2021. They did an initial deployment at the start of the year and then really kicked things in through June, July, up until the end of the year. And then through 2022 have been largely sort of filling in the gaps in that first round of deployment. So at this point, because they're the biggest provider in Israel, their journey kind of mirrors the country's journey. But of course, this isn't only V6. I also look at DNSSEC. Why? Because DNSSEC is really, really, really important. And understanding how much DNSSEC is out there and who is doing it is actually important. 2 tests inside that 10. One, a validly signed DNSSEC name, and two, an invalidly signed one, where the signature is deliberately bad, bad, bad. Why? Because if you're doing DNSSEC validation, you should actually try and resolve both names. But the invalidly signed one means I'm not going to fetch that URL, but I can see you trying. I can see you actually asking for the DNS key values for both of these names. And you should also have the EDNS 0 flags turned on. Now, that last thing, querying the zone's DNS key, easy to say, really, really hard to do, because I don't want caching. And so I actually need to create a fake delegated zone where every single time an experiment runs, it looks as if I've created on the fly a new delegated zone and signed it. And so I don't use a conventional DNS server to actually make this trickery work. We actually, with the help of Ray Bellis, clever coder from Cambridge in the UK, who's currently at ISC, used a DNS library and actually did a dynamic DNS server that constructs dynamically delegated zones on the fly. It's brilliant, love it. So if you fetch the validly signed one, you don't fetch the invalidly signed one, but we see you looking at both with DNS key queries, then we have a pretty strong suspicion that you're behind recursive resolvers that will not give an answer if the result is bad. But that's not all, because some folk never take no for an answer. When DNSSEC says, nah, it goes, I know you really want that answer. I know a resolver that doesn't do validation. Let me re-ask the query over there. And so what we actually find for the global numbers is that, oddly enough, it's about the same as V6. Around 1/3 of the world sit behind DNSSEC validating resolvers and will not go to somewhere if it's invalidly signed. But interestingly, another 10% go, I really, really, really want that answer. I'm just going to go to a resolver that doesn't validate because I really, really, really want that answer, even if I shouldn't. Where are they? Isn't that interesting? All of a sudden, Africa. It's a different kind of map. All of a sudden, Russia. All of a sudden, Norway and Sweden. Different bunch of folk are actually doing DNSSEC validation. Papua New Guinea. So who's doing it is actually a completely different map. Somewhere there is Bhutan. I remember seeing them and they were very proud when they brought in DNSSEC validation across their major providers. How about in Israel? The big one, Partner AS, no. Cellcom, yes. Hotnet, sort of. 21% is an odd number. It's not everyone, it's not no one. It's some. That's odd. Physique, AS551, yes. As you see, a mixture of yes and no's. Oddly enough, the smaller ones, where we get much lower samples over a 30-day period, are actually have more DNSSEC than the larger ones, like Partner AS, which is still going, no, not really. It's not just DNSSEC, though, because with a dynamic DNS, Nginx models, and two-step packet processing, we can do a whole bunch of measurements. How do I know if you get a DNS answer? Well, one of the ways to do this is to actually do glueless delegation, where all of a sudden I'm resolving a name, and the name servers of the next zone aren't given to me for free. They've given me the names, but the addresses are not known. I have to stop and resolve those names before I go back to the mainstream. So what if the name server names have internationalized domain names? Interesting. How good is the support for IDNs across the world? You can use this technique. We've used the same technique to see the support for query name minimization, an important part of DNS privacy. We've even used this to give you very, very, very big DNS answers to see how well you handle DNS fragmentation in UDP. And the answer is not well, not good. And of course, things like DNS dual stack behavior as well. If you can only get there with V6 and the DNS, would you get the answer at all? So DNS glueless delegation has actually given us a remarkably good tool to put into the ad to actually check to see if the client is able to resolve a DNS name without being able to instrument the client at all. The other thing we've had to do lately is repeats. I don't know if any of you have looked at the new QUIC protocol, which is basically encrypted UDP. It was Google's latest contribution to encryption. Now, how do you turn it on? Because it's trying to be quicker, not slower. And so the way they do this, oddly enough, is switch on second use. So the content actually contains a very explicit directive. So if I deliver you a web page and it has a header in HTTP that says, oh, by the way, the next time you come and visit me, I can do QUIC because I'm so clever. On the second fetch, it will use HTTP3. It will use QUIC. How do I measure that in the ad? I've got to repeat the fetch. And so I actually have scripting ability to actually have repeats flying around that will look at the same thing up to 7 times just to flush out that kind of HTTP3 use. I've also looked at serve fail DNS, deliberately giving you an answer that says, I can't give you this answer. Maybe you should try someone else. Because I want to know the full collection of DNS recursive resolvers that you're using. And one of the ways to flush that out is to actually give you back a serve fail answer. That's how, by the way, with Israel, I was able to figure out which resolvers you're using, how many folk use Google, Green Team DNS, and so on, is to actually give you serve fail answers. So you go through your entire etc resolve.conf, which sort of exposes to me, measuring you, which resolvers you're using. Also, very, very recently, there's been a big debate over IPv6. There's always a big debate over V6. And the current one is, do extension headers work, or are they an unmitigated disaster? So we thought, this is easy. What we will do for the folk who support V6 out there is, in the TCP session, to get that 1x1 pixel, we will send them crafted V6 packets that contain all kinds of extension headers and see if they acknowledge the packet. If they ack that packet, they've received it. And so this is where the packet capture comes in really handy, because we're sending them really crafted V6 packets that contain mangled V6, artificial fragmentation, all kinds of extension header options, both hop by hop and destination. And then we're looking to see if there's an ACK that comes back. And so the set of projects we've been doing are actually on this page, and all of them are at that URL there. So how reliable is V6? How many dangling connections are there where I receive the SYN, I send back a SYN ACK, and nothing happens? Nothing. Because we've also got endpoints with CF in both 4 and 6, we can actually do round trip time measurements. And the best place to do that, oddly enough, is in the TCP connection handshake. So you can actually see, is V6 faster than V4 or not? Because that whole thing about, do you prefer 6 or not, actually depends on an attribute called happy eyeballs. And happy eyeballs is based on timers. So when India decided, God knows why, to send all of its V6 traffic to the UK, but all of its V4 traffic went across the Bay of Bengal to Singapore, the difference in round trip time was, half a second. And so all of a sudden, when you had a dual stack machine, but the V6 path was going around the globe, oddly enough, the preference was to use 4 because no one waits that long. So interesting experiment. Fragmentation, I've talked about extension header loss. There's been some discussion with DNSSEC over, is RSA still a useful encryption algorithm? Or is it now so big, because we're trying to stay ahead of computers and memory, that RSA has passed its use-by date and we need to go to a denser crypto algorithm like elliptical curves? How many folk will actually do DNSSEC with different algorithms? We've measured this in the past and probably will continue to do so. DNS fragmentation, who uses resolvers. We did some work on the key role of the root key in DNSSEC. And in the last couple of months, we've been looking at Quick. We also sent people to destinations where the route is invalid. Routing security says no, will you still go there? And the answer for, geez, about 80 to 90% of the world is, sure, why not? I don't care about routing security anyway. And as I mentioned obliquely, that timer element in the DNS name is really fascinating. Up to 40% of the queries we receive are old and stale. But who asked them? Who's looking over your shoulder? Who's tracking you? And there's a whole bunch of work we've been doing when we get curious as to where that tracking happens. So I think I've sort of largely used up the time here, but what I wanted to make is a few general points. This is one of the first of the opportunistic server-side measurement platforms. And like things like Kaida's Arc or Ripe NCC's Atlas place probes in the homes of geeks. And, you know, the problem is there's a certain geek bias in those homes. ISPs can do network level internals, but it's very, very hard to look at the network the way users see it. And if you're trying to actually measure the network the way users use the network, then what you want is massive testing of client behavior. And this is what we're actually doing. We're doing the client unaltered. We can't instrument them anyway. All we can do is prompt them to fetch URLs. All the instrumentation is on our side, on the server side, where we exhaustively analyze all the packet captures and logs to actually infer what's going on. But the beauty of this approach is that whereas whereas network side and client side measurements kind of look at something and try, well, what caused it? The beauty of this approach is we know what caused it. We did it. And what we're now looking at is we've triggered the cause. And what we're going to do is correlate the outcomes against that cause. And that actually gives some remarkable insights that I think are unobtainable anywhere. Look, I've used up all of my time and a bit more, and I thank you for being so patient. There's a URL if you want to look at some of the things we muck around with. And if there are any questions, I would be more than happy to answer them. Thank you.
Wow, that was unbelievable. I really enjoyed it. I hope everyone else did. I'm sure other people might have questions, so I'll let people start asking. Anyone?
I think all of us are stunned by the lecture.
My time was limited. There's a lot of material.
So I recall when the list of resolvers used per country was released earlier this year. Some of the results seems odd relating to Israel, and I can't recall exactly. So if you have the data available and present, I can take a look and ask a question there.
I think it was about Green Team, right? That we saw, which is supposed to be a very popular resolver in Israel. And when we had the discussion, no one really knew what this service is about, if I remember correctly.
Yes,
It's actually a filtering resolver, a bit like Quad 9, and it turns out that one provider is very, very keen on them. If I can stop sharing that screen and share a different screen, this one. I got it there. Sorry, share. Yes. So let's go down here and Green Team, Cellcom. When folk who come to this site in Cellcom and go to one of my names, and I consistently say, serve fail, serve fail, serve fail, 94% of their queries come from an IP address that is effectively owned by this green team DNS thing. Now, the name has changed a bit, and I actually think the business has been sold. It's not well known. And interestingly, only Israel is prominent for green team DNS. But, you know, that's a big provider. Cellcom is not small. And when they're sending all of their DNS across to Cellcom, that's why we get up to 30% of the users in Israel are sending their resolvers to that. Now, there are three kinds of DNS queries going on. Who do you believe as a user? Well, that's the first resolver. Who sees you? That's the initial query, because in the DNS, if you have just one query, lots of folk might get a copy because the DNS is endlessly generous with whom it shares your information. And so what you find is a single initial query might go to more places than, you know, the one you're going to believe. And last and not least is this all resolvers query, which says who might see your query, particularly when the name's not well resolved. And you notice the Google number has risen, goes up from 10 to 20, because Google's public DNS is used as a backup resolver by an awful lot of folk. 10% of the users are partner. Like I said, Cellcom don't, but Hotnet has an extensive use of Google, and going down into the smaller ones, Golan Telecom and so on, make use of Google as a backup. So I think with Green Team, the issue is the label is confusing, but there is no doubt that the network assets that Cellcom use for the DNS is a service that used to be Green Team, and I'm not sure who's running it now, but it's not inside Cellcom. It's an external service provider that Cellcom is using for its DNS. Not sure if that answers your question a lot, but you know, that's the data we see.
You estimate that Cellcom local DNS is forwarding to the Green Team DNS? Because yep. I recall talking to the admins there, sorry, and again, it was a few months ago, so I might be incorrect, but I don't recall them. They were not aware of it.
They're normally forwarding, and part of the issue is, and why forwarding is so good, is you don't have to spend time, money, or expertise on your DNS. You just forward it. And this is why when we go back and look at Africa, right, and actually look at the sort of the world map of who uses Google, then what you actually find is Africa uses it a lot because it's cheap, it's fast, it works. And I think in this case, because of that very, very high percentage in Israel, that's a forwarding statement. That's the ISP doing it rather than users making an individual choice. And you see across the countries in the region, Israel's the only one that uses it. Google, it varies a lot. Azerbaijan is a heavier user than others. I always find this a bit surprising because if you really are concerned about privacy, sharing your secrets with Google seems to be a bit of a contradiction in terms, but you know, there are a lot of folk that use Google. Of all the open resolvers, Google has, you know, market share that, you know, no one else can. If we go back to you know, the big picture and look at the share of Google is believed by around 15% of the world's users. But if you look at sort of Google's potential share, Google is up around, well, it was high at 30%, currently kicking at around 20%. Last few days, that was my fault. Bad data since August the 22nd. But yeah, about 25% use Google.
Anyone else with any other question? Green Team, I guess, between Cellcom and Bezik International, the only way to get an answer would be to get to the right people there who basically so far have not coughed up the right answer. but according to the numbers that Geoff is bringing before us, those two ISPs are using Green Team extensively. Any other questions?
Right.
I have a small follow-up question. Is there a way to know from this data if my DNS resolver, which perform my DNS queries, is forwarded or defined by my ISP, or in cases which I change the default setting either in my router or in my machine, just to know if people go to other resolvers because they wanted to, they made an informed action and changed the resolver on the system, or it was forwarded by their ISP. Is there any way to tell why or in which way people go to resolvers other than the DNS resolver?
Oh, I assume you're able to set up your own DNS name and server, and you should. And you should set up a totally unique name, right? And you should, on your mobile phone or whatever you want to test, just go there once. And then you should look at the logs of that server for the next 24 hours. And sometimes you are amazed by what happens. In Australia, for example, if you'd done that 5 years ago, you would have seen that within 1.3 seconds, a server in Dallas went there too. A completely unique name. Only you knew it. And all you did was go there on your machine. How did a server in Dallas go there too? Fascinating question. If you're using a particular browser that supports the Chinese pinyin script, and there aren't that many that do that, but if you're unfortunate enough to use one, within 2 seconds, a server in Guangzhou province in China will go there too. Now, you can do this yourself. You don't need me, because all it is actually looking at who's shadowing, who's actually getting a real-time feed of the DNS queries that go to your ISP. And you can also work out who goes there first, whether your ISP is forwarding or actually running their own resolver. Again, useful information, because, you know, there's an awful lot of folk who look at the DNS one way or another. Oh, and a big clue these days, try not to use your browser to do this, but use a command line interface, because if you're using something like Chrome or Firefox, there is a strong preference to actually do default settings, irrespective of what you might think. Here is, oh, actually, no, I think it's Cloudflare was what I was looking at. Cloudflare, have I got it somewhere here? Sorry, around 20% of the queries that get sent to all ones are over DNS over HTTPS. So your browser is actually taking over your DNS and sending it to places that you never thought about and your ISP doesn't know. So the short answer, you should play around with this if you're at all interested, because all you need to do is just run your own DNS resolver and ask for a unique name that only you knew. It was a secret, and see who else asks for it later.
Okay,
Sobering.
Time for one more question. Otherwise, we're already 5
I do have a
minutes over.
remark about the DNS.
Yuval, can't hear you. Can you repeat it?
I have a remark about the DNS stuff that they discussed with Telcom. So what we are doing, we're running a large query campaign on a DNS that we own. And what we do with this DNS is that
Your audio is very, very spotty, Yuval.
okay, I can try and get closer. Is it better?
Yes, it
Yes.
is better. Try.
Okay, so we run large DNS query on a domain that we own, and what we return in the answer, we code also the IP of the resolvers that actually send us the query. So we're querying 4 of Telcom DNSs. 2 of them are actually doing direct query to us, and the other two are doing it through IP addresses that are registered for a level 3. I don't know if this is part of this green team stuff that they are hosted there or whatever, but this is our results where we actually see where the queries come from. So half of them come from Cellcom and half come from level 3.
That would explain it, but I'm sort of getting routed through what you would call level 3, and it wouldn't surprise me that level 3 has bought Green Team. There is a strong popularity these days with what they call clean feed DNS, where what's going on is that folk are trying to sort of take all the malware signals and not resolve names that are associated with viruses and similar. And so Cellcom might well be doing this as a genuine service to customers, going, well, this is the way we do a cheap form of doing some basic protection for users. Just closing, I was looking for this and I thought you might be interested in this. Cloudflare have a cooperative agreement with APNIC. Why? Because they wanted all ones, 1.1.1.1, and it's our address. And so we said, you can use it, but you've got to share the data. And this is the result of sharing the data in Israel over the use of DNS over UDP against Cloudflare, 60%, just a bit under. DNS over HTTPS, not TLS, but over HTTPS, getting up to 40%. And DNS over TLS, which is commonly a setting in Android platforms and nowhere else, around 5%. So oddly enough, encrypted DNS is actually taking off in the browser world. Not in the conventional world, but in the browser world, there's more and more traffic being tunneled through ISPs, being tunneled through the existing DNS infrastructure and heading straight over to HTTPS. As you can probably tell, we only started gathering this data in May. It was difficult to gather from Cloudflare. It's taken us some years to get the project together, but endlessly fascinating as to who's doing what with tunneling through encrypted DNS. So I'll leave that with you as a small teaser as to the kinds of fascinating things we're seeing these days. And with that, I'll hand it back to you, Hank.
Wow. I'll just say that I found this amazing and wonderful, and I hope that everyone else on the call found it exceedingly interesting. And I'm sure that this presentation that you made will probably appear itself someplace in Nanog or in Right in the near future, if I'm not mistaken, because the topic is indeed fascinating. So Geoff, once again, thank you for your time, and I'll let you go have your dinner soon in Australia, and to everyone else in Israel, see you soon. Okay. Thank you, Geoff.
Thank you so much. Thanks a lot. Thank you.
Thank you very much.
Thank you.